Okay, so in this portion of the lesson, we're going to go over something called water footprints, or sometimes called hidden water, and water conservation. So we'll go over what a water footprint is. We will go over sort of some just examples of things that have water footprints and the importance of considering it. And then we'll get into some irrigation techniques and then some other types of farming techniques that can be used to reduce water usage. So you may be surprised to learn that the vast majority of water that we use is unseen to us, at least people that aren't farmers. Um, most people think if you want to conserve the most water, take shorter showers, don't let the water run when you brush your teeth, etc. All of those are helpful, and I want to be really clear that every drop counts. But most of the water that you're actually responsible for, your personal water footprint, um, is hidden from you. And this video does a pretty good job of just sort of illustrating some of those, and we'll look at some more information about that after this video. So I want you to consider sort of various uses, things that you probably do um, that use water that you don't see. So again, don't worry about the exact numbers, but the point is that everything around you, if you just press pause and look at everything around you, every piece of equipment, every piece of furniture, the electricity, any electricity is being used, any fossil fuels that are being used to, maybe heat your home or whatever, the computer in front of you, the phone in front of you, all of that requires water to use. It's one of those things, again, that I think most people don't realize, but um, And yeah, there are many places you can calculate your own personal water footprint, but the point is to just that's something that I really want you to understand. And this was also illustrated in the reading that you had this week from Sandra Postel, what she calls the water food dilemma. So she specifically identifies water footprints of different types of food. Right, and these again, you don't need to know the exact numbers here, but it gives you a sense of scale. Like single tomato, 13 gallons. Potato, even a slice of bread is 40 gallons. One egg is 135. It's crazy. So the cup of coffee, obviously, that's not to make the coffee in your thermos. That's to actually grow the coffee. That's a milk, hamburger. So beef is one of the I think it's the one of the most, if not the most, water intensive foods that you can eat. And if you think about, let's just kind of look at the hamburger real quick. Think about like what is using all of that water? I mean, is it the cows drinking a bunch of water? Um, and the problem is not, the cow itself after it's um, the water that it personally consumes. It's all of the feed that is grown to feed cattle. So now if you have grass-fed cattle, 100% farm, grass-raised cattle, um, that is significantly reduces the water footprint. Um, and it really depends on how you do the counting, to be honest, because obviously grass needs water to grow, but not as intense as some crops like corn on a per calorie basis. And most likely the the water's being used to grow the grass is just rainfall instead of irrigation. And so the point is that it's not the cow itself what it consumes in terms of its water consumption, it's what it actually eats. And so different types of cows that are raised different ways will have different water footprints. But you can think about this, one hamburger that's I think it's a half-pound hamburger. Cotton, really intensive plant, and then leather shoes again from cows. And so there's this food, what's called the Water Footprint Network, which is a really good site if you want to calculate water footprint. And then they have this food gallery. So you're going to go over that in your assignment this week, but it shows you a lot of different products and it may surprise you how much is used. All right. So again, the vast majority of water that you use, you don't actually see. Um, and so, Pastel does offer some solutions, more efficient irrigation. We'll go over this in a minute. But spray irrigation, as we kind of alluded to earlier, is really inefficient. So water intensive diets, that's a really important way to conserve water. And just to give you some idea for some numbers, again, you don't need to write these, know these exact numbers, but if you want to get, the same amount of protein, let's say, whatever, 50 grams of protein from beef, and then 50 grams of protein from rice. And rice is not a heavy, it's not a really protein rich source. But even so, beef is obviously a lot of protein. It actually takes 4 times more water to get the same protein from beef relative to just rice. So imagine how intensive it must be if a high protein source actually takes a lot more water, right? Um, and just to get the same calories from beef compared to rice, it takes almost 20 times more water. Um, and so, you can, um, if you can reduce your beef intake in the US alone, if 50% of people in the United States reduce their beef intake, it would be 261 billion cubic meters a year. That's a lot. So that's multiple Colorado rivers worth of water. That's just by changing a diet. And so that's where, you've heard of like meatless Mondays, for example. Meat in general is more water intensive than vegetables because all meat eats something else that uses water, and then you have to, even a chicken has to eat a lot more food, a lot more calories than you're actually getting in the chicken. So it's always more intensive, water intensive to grow beef. Another solution she has is to make use trade to make smart water use decisions. And I think this is interesting. If you have a country like, let's say, Southeast Asia, um, parts of Southeast Asia anyway, where you have a lot of rainfall. It's really wet. It's really um, moist there. And so, you can grow some more water intensive crops there. And then, somewhere like Western United States, where they actually do grow a lot of crops, even though it's almost a desert and some places are deserts. Um, sort of use more arid, appropriate crops in those areas, and then the more water intensive crops you can grow it elsewhere, right? So that's a broader scale decision, but it is something that can help. And just in general, we've talked about economics just kind of underlies a lot of these sustainability issues. So just sending smart market signals um, really helps. Water is heavily subsidized in the United States, and farmers generally don't pay what the water is actually worth. Now, there's some rationale for that. It's a really important industry. We want to grow our own food. We want to be food independent and all that. But um, maybe sending stronger market signals, at least to incentivize more efficient use. If you remember that video from the Wall Street Journal, they mentioned that there were some, incentivized policies to help people reduce water use. And if you recall, there were some farms in there that said they'd reduce their water use like 25% over the course of like 10 years. So um, that's smart. That for a lot of people, um, and most in the sustainability world in particular, it's seen as a smart policy to incentivize more efficient water use, right? So it can be done, and there are case studies all over the place about this. And so again, she had mentioned using more efficient irrigation. And so we saw this in that earlier video. I'm recording this in Delaware. You see a lot of these in the southern part of the state. And if you were flying over the southern part of the state, you'd see a lot of this. So I don't know if you've ever flown over somewhere and seen something that looks like this. See all these circles? I actually remember the first time I ever saw this, um, a few decades ago, and I was like, why are there these giant circles? Um, it's like in the middle of field. I think I was flying over like the Midwest, and this didn't make any sense. And so these are circles because they use what's called central pivot irrigation. You want to jot down that term, central pivot. And so this is actually a central pivot irrigation equipment. You can see the wheels here, and down here it's attached to this is obviously a pipe, and there's sprayers spraying all the water out like that. And so there's a central pivot point down here, and this slowly rotates around in a circle, and it sprays water. And that's so on these images, this is right in these middle of these circles. That's where your central pivot would be. And so that's the pivot point. And then the equipment's going to rotate around slowly, one of these directions. And so this is really inefficient. So about 40% of the water doesn't reach the ground on average. It's evaporated, it's blown away. I mean, just imagine spraying up into the air. I mean, any kind of wind is going to take a lot of that away, and it's going to evaporate a lot of it, and heat's going to evaporate a lot of it before it actually hits the ground. So it's very inefficient. Um, and as again, thinking this even more broader sustainability implications, most, if not basically all of these are run by a diesel generator. So these are which are inefficient. It's a fossil fuel, so there's a carbon footprint associated with it. So that actually increases the carbon footprint of your water as well. Whereas non-spray irrigation, remember, about 40% doesn't reach the ground. With central pivot, non-spray, usually called drip irrigation, you can be subsurface, but only about 10% doesn't reach. So that's where you lay the irrigation pipe or irrigation tape directly on the ground. So this is good because you don't really want the water on the leaves anyway. You want the roots are what need the water. And so that's actually better. It actually can prevent diseases as well because if the leaves stay wet, let's say you irrigate and they stay wet overnight, there's much higher propensity for, um, bugs and bacteria and so forth to attack them. So that's an issue, but this is delivering it directly where it needs. It's not spraying up in the air. It's dripping slowly right onto the root where the roots are, and so that's much, much, much more efficient. Um, it's not appropriate everywhere. There are pros and cons with all of these, but in terms of strict water use, this is much, much more efficient in basically every instance. There's some other kind of in-between techniques. You can monitor soil moisture. They did mention that in the earlier video that they put moisture probes, and then you're not, irrigating when you don't need to, because the water's already topsoil's already saturated, and you irrigate it's more likely to run off. It's not going to soak in because there's nowhere for it to go. And so only water when it's needed. I'm not a soil scientist, so I don't know the exact like at what moisture level do you water, but um, it's certainly there are more optimal times to water than others based on the soil moisture. Okay, so irrigation is really important. That's the main user of fresh water in the United States and by far across the world. There are some other things, this was in your reading. And so some regenerative farming practices, you want to jot down regenerative farming. We went over that a little bit in the food section. We'll go over that in more detail in the last lesson. But these are, you know, these aren't specific to regenerative farming, but these are commonly used in regenerative farming. But you can do this in just to conserve water. So contour farming, which is when you plant perpendicular to the slope. This is a really good illustration of that. Obviously you can see the slope going down this way, and so you see how the rows are planted that way. So I want you to think about why would that conserve water, and it may be helpful to think if the rows were planted facing downhill, right? And so then you have, these areas, basically these plants, when you put them perpendicular to the slope, water's going to flow downhill. And so the plant is going to hit the plant, it's going to slow down, and it's going to hit the next row, slow down, right? As opposed to if you put them like rows that are linear this way, and water is much more likely to just flow off and not soak into the soil. So, one of the best ways to reduce water use in farms is just to make sure that it, hits the water actually hits some sort of vegetation. So it slows it down and allows it to soak in. So that's contour farming. That can reduce runoff by up to 50%. By the way, this also reduces soil runoff, so it conserves soil. That's also really important. Cover crops. Um, and so cover crops are when you're not growing the plants that you're actually farming, you want to make sure there's something on the soil. And so you want to jot this down, just in general. Never leave the soil uncovered, if at all possible. Um, because if there's no plants in the soil, again, if you think about bare soil, the water's much more readily runs off something like this than if you have plants holding the soil together and also the water hits, the plants and it kind of slows down. And so cover crops means just don't leave it bare, don't leave bare soil. Now, you can have cover crops in the middle of the season, so you can, like in this image, you could grow maybe some cover crops here in between the rows. Um, you can also um, plant crops in the off season as well, right? So there's a lot of different types of crops that you can grow. Things like even when you think you can't grow anything, like the middle of the winter on the East Coast, you can grow things like winter rye, winter peas. So there are things that will actually stay green all year. And then you can actually, um, sometimes you can harvest it, sometimes you use it for feed, but you can pretty much always at least chop it down and use it as a natural soil amendment and compost as well. And actually, I just want to show this image here. You can use radishes. So let's say you're growing, corn and wheat, and you harvest at the end of the summer, and then you're like, all right, well, I'm not growing anything till next spring. So you can grow things, even just something as simple as radishes, which you can obviously as a food crop. Um, and then you can plant those, and then it helps prevent soil moisture loss as well. So not only does it allow water to soak in, but it also helps slow down evaporation from the soil. Okay. So conservation tillage is, again, it's basically, there's a couple aspects to this. Some farmers use what's called no-till farming, which basically they never till the soil, and tilling is, digging it up. Um, and so again, there's a couple different ways you can do this, but here's an example down here in this image. And after the crop is harvested, you just kind of leave those stalks there. And instead of tilling it, digging it up, you leave the stalks there. And again, you just don't want to leave the soil uncovered if at all possible. So that'll both help prevent runoff, but will also allow water to soak in. Again, it helps prevent soil erosion as well. It helps maintain the microbiome and the soil biome and little communities of organisms as well, support wildlife. And I thought this is a really cool image showing, most of the plant you don't see. So these are, different cover crops. You don't need to know the cover crops here, but the root systems, and this is actually really good. There's a lot of research on the improved soil fertility if you leave the roots in. So and if you garden at home, you should really try to never pull the roots out, um, except for, weeds that'll regrow if you leave the roots in. So you got to be careful. But it turns out that these roots, they're the ones that are pulling all the nutrients out of the soil, and they actually you develop these really elaborate communities of organisms that help the plants grow. And if you pull the roots out, those communities die, and they have to restart when the roots start um, growing again. So you want to try to keep the roots in. And I just thought this was really interesting that these, this little, like a grass here, and you can see all of these, pretty extensive root systems under the soil. So the point is, in addition to water conservation, there's a lot of reasons to do that. And there's just very definitive, a lot of research out there showing that if at all possible, if you can minimize your tilling, for a variety of reasons, but basically there's these really elaborate underground communities that sort of organize into vertical layers, and when you dig that up, it destroys that community, and then it reduces your soil fertility. So it's really important, if at all possible, not to till. So mulching, is just, again, you want to use the mulch, right? So keep the soil covered. There's innumerable ways to do this. This is a good example of, like, at home garden, you want to mulch. Um, and this both prevents evaporation, because if the soil is bare like this, it can much more easily evaporate, but it also, if rain falls on this, it's going to more likely to soak in, less likely to run off. There's a lot of benefits to doing stuff like this. Um, this adds an organic layer. So this is going to decompose over time. It's going to increase your humus layer, your organic layer on top. It's going to build the soil. It's going to develop those, those bacterial and other communities. It's going to reduce runoff. I mean, there's just a lot of reasons to do that. So that's mulching. Again, you want to keep the cover soil if at all possible. And the last one, these shelter belts, which aren't actually keeping the soil covered as much. Sometimes these are called windbreaks. There's a bunch of different ways. So don't think that these pictures are the only way to do this. So what this does is it growing some sort of taller vegetation in between. So this is the stuff you're trying to harvest. And then this is your shelter belt. And so this is really just wind protection more than anything. And when wind blows over top of soil, it evaporates water, it facilitates runoff. Um, and also, again, it facilitates erosion. And so all of these have multiple benefits, all worth keeping in mind. Okay, so these are things, by the way, all of these things you can do if you just grow your own food at home, even if you have just a potted tomato plant on your, whatever, your porch. You can mulch it with some straw, and that's actually really, really helpful for potted plants in particular, as it turns out, because they can dry out really easily. So this helps maintain that soil moisture. But all these things you can do um, to help reduce. Windbreaks, or shelter belts aren't as practical for backyard gardening, but all these other ones are. Okay. All right. So those are the idea, the concept of water footprints. So remember that most of the water that you're actually responsible for, you do not see. Everything around you uses water. You can calculate your own water footprint in various websites. Um, and that, there are more efficient irrigation techniques, but there are a lot of things that you can do and that farms can do Remember, farming is by far the biggest user of fresh water across the world. And so by using these techniques, um, you can not only reduce the water use, which actually would then reduce the water footprint of the food that you eat. So this has wide-ranging impacts. But there's a whole bunch of other reasons to do this. Soil health, minimizing the use of artificial fertilizers and pesticides and herbicides, preventing soil erosion, which is a really big deal. Um, just if improving soil fertility, then you improve your crop yields. There's less artificial inputs, less fossil fuel used to till, less fossil fuel used to make the fertilizers. I mean, there's just like benefits upon benefits upon benefits. So um, this is a really important set of considerations.